Okay, so we're looking now at experimental versus theoretical probabilities, and you'll begin to have a chance to play some a game on the next page. Excuse me, the cough. So experimental probabilities are the results that are analysed from doing experiments, and theoretical are what should happen if you had an infinite number of trials. So they're not the same things. Okay, experimental is the results that come from what you actually do, but theoretical is what should happen regardless of what you actually do record in experiments. Okay, so for instance, if you throw a coin 10 times and record the number of times a head occurs, you could get a range of, in 10, you could get a range from 0 to 10. Like someone would get 0 and someone might get 10, but most people would be between 0 and 10. Would everyone get 5 and 5? Okay, does everyone always get the same number? Okay, so think about that, but the result for one person does not determine the probability that a coin is fair or biased. Like if it was fair, you'd have 5-5, but just because one person gets 10-0, it doesn't mean necessarily the coin is biased. Okay, so if all the results from, say for instance, a class of 25, well, I know there's 26 of us, but if there was 25 students and we all collected our data, the results might come back towards the theoretical value of 5 on average, but that doesn't have to happen. It's only when you have an infinite number of trials that you would see the experimental probability and the theoretical probability come together. Okay, so even 25 people collecting their results would not necessarily come back to exactly 5. Okay, 25 students times 10 is only 250 tosses. It's not enough tossing. Okay, so it's only when you have an infinite number of trials that you'll get experimental and theoretical coming together. If that wasn't the case, then people would be winning money at the casino left, right and centre, because they'd say, well, for instance, if they were doing roulette, which is the dice, the ball in the spinning wheel, like if you had black, 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 the people will think, oh, well, it must be a red coming up next. They'll be putting all their money, but that's not going to happen. It could be a red or it could be a black. Okay. So, coming across. So, what I want you to do is, don't do this yet, but we're going to type in your web browser a search for interactive Monty Hall problem, and I want you to select the one that's got SHODA. Now, I don't want you looking at other websites with Monty Hall because you'll see what the answer is, but I want you just to go to that. But before we do that, let's just go through what's happening in the game. Okay, so that jumped up too quickly. Okay, so what this is a game with 3 doors. Okay, so behind one of the doors there's money, and you have to select one door. Okay, so what happens is there's 3 doors. Okay, in the question, there's 3 doors, and you select one of the doors. Okay, now what happens is one of these other 2 doors is open, and it doesn't have the money. Okay, so you're very sad. Okay, so the question is, do you stick with your original one? So for instance, if this one's opened, so the question is, do you stick with that one or do you switch? Okay, so should you keep your original door or should you switch? Now, before we start, again, it's jumping up, I can't get it to go slowly. So before playing this game, and I'm going to play the game 30 times, it doesn't take long because you just keep resetting it. I want you to predict the probability of winning the money, but just using one strategy. So either pick the strategy of staying or pick the strategy of switching, but I want you to predict what you think the answer is going to be, what you think the theory is, and then you're going to play the game 30 times. Okay, so the door, you pick a door, another door opens and it doesn't have the winning money, so should you stay or should you go? Okay, so, but I want you to pick. So, for instance, some of you might think the answer is 50-50. Okay, that's fine. But I want you to do that answer first, then play the game, and then when you're ready, come back and we'll go to the next slide. Okay, so hopefully you played the game and enjoyed it, and you may not understand what happened, but what you should have found after playing the game repeatedly is that if you stayed, then your answer got close to 1/3, and if you switched, the answer got close to 2/3. So the answer was not 50-50. Okay, most people will think it's 50-50, but theoretical probabilities don't agree with what you think. What's happening is, I'll just get down, hang on. So what's happening, why is it 1/3 and 2/3 is, okay, you've got your 3 doors, okay, and you pick that door, so the chance that you win is 1/3, and the chance that these 2 guys win is 2/3. Okay, so the chance that you pulled off the miracle on the first one is 1/3, which is still a possibility, but the chance that you didn't is 2/3. And once one of these doors is taken out, this door, the other door, takes a probability of 2/3. Okay, that's why it's 1/3 and 2/3. You only had a 1/3 chance, so it doesn't matter what happens. The other doors, the 2 doors have 2/3, and if one of those doors is opened, this door still has 2/3. Okay. So, in terms of some mathematics, excuse me, the relative frequency, so the word relative frequency, it's not one word, it's 2 words, is related to the results in the experiment. So the relative frequency is a fraction, or can be expressed as a decimal, is a number of times an event occurs divided by the total number. So for instance, if you throw a die, okay, so you have a die, so there's no zeros in dies, take that out. So 1, 2, 3, 4, 5, 6, that's the event. And number of times it occurs, like a 0, 3, 5, 1, 4, 2. So we've got 8, 9, 11, so we've got 15 events. So the probability, the relative frequency of getting a 3 is 5 over 15, which is a third, which is 0.33 repeater. Okay, so relative frequency is pretty straightforward. It's the number of times the event occurs over the total number of trials. Copy that down. Okay, so what I want you to do is read through the examples in the textbook on page 474. This is the electronic textbook. And then I want you to have a go at exercise 11C and just do a range of questions. Okay. And that's it. Okay, thanks. Yeah.